Okay, so for instance, if we were to look at palladium, okay, what's the first thing that you can tell me about palladium? It has 46 protons, okay? And if we look at our handy dandy cheat sheet here, or your periodic table, if its oxidation state is +2, which it can do, how many electrons is that if it's a +2 charge? It is 44 then, okay? And then there would be 42 electrons if it was +4. Does everyone understand why or how that kind of teeter-totters back and forth and back and forth? Okay, so we know that with the atomic number, or the number of protons, tells you which element you're dealing with. So that gives you the number of protons, okay? So that's not going to change between any element of palladium. But you may be dealing with an element that's +2 or +4. So we'll go ahead and just do it as +4. So you could look at that as far as algebraically as well. In other words, we could say 46 plus your number of electrons, we'll just put it here, equals a +2. Okay? So, I guess I don't need to put positive over there. I guess that wouldn't make it. Let me rewrite that. Number of electrons +2 equals 46. There we go. So how do you get E by itself? Yeah. So once we subtract that over, now we got electrons equals 44. So back to our original idea, there's 46 protons, okay? So number of electrons, we're going to add that. Now when you add them two numbers together, what do we get? +2. Okay? Same thing. All right? Nope. The electrons change. Okay? With a negative charge? Okay. So you can pick any halogen in column 7. Fluorine would be the easiest to see. Okay? So if we're doing the element fluorine, okay? The atomic number for fluorine is 9. Okay? So what we can do is say the number of electrons, okay? What type of charge does fluorine form? Okay? How do we get E by itself? If you subtract that from this side, then they cancel, then E equals what? Okay? Charge. So what does that tell you about your electrons? You have one more. Okay, that's why it's a -1 charge. You have one more than the number of protons. So it would be 18. You're exactly right. Okay, so what type of predictions? Now, this is where it gets to be a little tricky because where on the periodic table is palladium? What block? Okay, now, the reason we say the tricky part, and your slide rule compensates for that, okay? So 4s1, 4s2, once you hit scandium, is that the fourth period? No. Your slide rule tells you that. Because if you look at your slide rule, I see some disgruntled looks. When you look at the very bottom of one of your slides, it has 4s on the bottom part of the slide, right? What happens when you go to the top of the next slide? You're in the third energy level. So one way to look at that, this is a little tricky here, I get that, okay? This is 4s2, this is 3d10 here. When you're looking at your D blocks, however it is, the simplest way is just go by what your slide rule says. Or when you look at this, think of n minus 1. That's what we would tell the juniors last year, this year's seniors. Okay? So we say n minus 1. If this is the fourth period, if we put 4 in for n, what's 4 minus 1? 3. So that's why this is the 3D block here. Or you can go by what your slide rule is trying to tell you. Okay? Now, so left outside, do we understand that? Yes. Left middle, middle, right middle, and right outside. Because we're nodding our head yes, and when you tell me that, you're saying that you understand. And if we understand, we keep going. Okay. So with that little bit of information, what period is the last electron going to fall into when it comes to palladium? Is it the third or the fourth? I hear 4. Could it possibly be the third? I think it's the third energy level. Okay, reason we say that, okay, remember this is what your slide rule is saying. Okay, so when these lines are going like this, which one's coming first? The fourth or the third? The fourth one's coming first, so that palladium, the last electrons actually are on the third energy level. Your slide rule tells you that. Okay? I see some disgruntled looks out there. I hear. Yes, they are. Okay? But one of the things we said when it comes to D block elements, we said think of n minus 1. Where are we getting 5 from? Oh, I'm thinking it was in the 3D. I'm sorry, you're right. It's actually the fourth energy level. Yeah, okay. I was thinking it was in between 21 to 30. So yeah, it is actually the fourth energy level. You're right. Okay. So, what would you like to see first? We're going to look at all 3. The orbital diagram, where you get your quantum numbers, the configuration, and the Bohr model. Or you just want the recommendation on what I think would be the best for you? Okay, so then in that case, my opinion would be, let's start with the Bohr model. Okay, so inside that nucleus, we know we've got 46 protons. Okay, following your slide rule, now believe it or not, that on, which I know you do, on Wednesday, you're going to be responsible for doing this on your own. We're doing this together as a group, which probably seems a lot easier. So one of the things I like doing is it's not that we're going to shut this, but we'll turn it down so we can hear you, but we can't see you. Because if we're going to record this, we can't post it with students on there. I don't know, that's just one of the stipulations that the Science Channel or what YouTube has as you can't have people under 18 on here. I don't know, that's just a rule. Okay, so does someone else want to come up and describe this, or you just want me to keep going? So if I'm going to keep going, we want some input here rather than all these other sidebar conversations. Wouldn't that make sense? Okay, so then what do we do here then? Okay, then what? Okay, this is telling you you need a new energy level. Okay, then what? And now all these numbers are going to come together and add up to what? 46. We're up to 10 so far. Okay, now we're up to here. We slide down. What's that telling you? Okay. Okay. So let's say you stopped there. I'm willing to bet we could add all them together, and as it stands right now, I bet you get 38. Yes? Oh, I thought you said question. Well, let's find out. Okay? So 10, 20, 28, 30, 36, 38. Okay? So when you see element 38, where are we at on the periodic table? Yes, okay? We're up to strontium so far. Now, keep going on that row or that period. It's not the fifth period. It's actually the what? Fourth. You were right the first time from about 5 minutes ago. It's actually the fourth period. Now, what column in that D block is palladium located? Just in the D block only. Okay? So if this was already 38, we add 8 more to it, like you correctly said. 38 plus 8 gives you what? 46, and that's what we're shooting for. Okay. Now, as we proceed forward, if we were to do a linear depiction of all of these electrons, that's called a what? This is the Bohr model. What's a linear depiction called? Electron configuration. Who likes longhand? Okay? Who likes the shortcut? Okay? Well, we'll do it longhand, and then we'll come back and do the shortcut. Okay, so we're going to do this. So palladium, 46. So here's your electron configuration. 1s, 2, 2s2. And notice we're going right in order that we put them up here for your Bohr model. And all these exponents will add together to get what? 46. Okay, so we're right there, 2p6. So 3s2, 3p6. Now we go 4s2. Okay, 3d10. Oops. Okay, so we're right there. Now we're going to go 4p6. Okay, we're right here. What comes after 4p6? You correctly said 5s2. And then we go back down to 4d8. I'm sorry, repeat that. Do this here? No. Nope, you're just responsible for knowing all three of them. And notice that a progression that we're doing when you were 2 years ago, you did the Bohr model and you did the configuration. And we've already proven that. We can go over that file cabinet, pull your file folder out and look, and you've done this information already. Okay? So, is there a shorter way to do this? Because we want to see both of them. For the shortcut method, which noble gas, remember you can't go up, you have to go down. And what would that be? Krypton, which is element what? Okay, so when we do that, okay, what period is krypton in? 4p6. So that means the fourth energy level has all electrons in it in the p block. So what comes after 4p6? 5s2. Then what? What's 12 and 30? I'm going to say something's not right. 36 plus 10 gives you what? 46. So these are the exact same elements. This is just a simpler way of writing it. Okay? Now, let's get the quantum numbers from this. How many of you were confused with the quantum numbers? I mean, I got a piece of paper up here that looks like a lot of them are correct, so it really shouldn't take very long to look at those. So, in my estimation, any one of you should be able to come up here and do that. How many of you would struggle? Not hardly anybody. So, rather than listening to myself, does one of you want to come up here and do that? Okay? Well, remember, these are the last electrons. Okay? Just explain what it is that you're doing. Okay?
Do I need that marker?
You got a whole bunch you can pick from.
Oh, wonderful. All right. So the first number for that is 4. That goes there. The number that's given to you is 2. Or is it 1? Is it 2? 2. Okay. And then M, you gotta have the 5. And go 8. And so this one, and that is 0.
shifts that we're responsible for on Wednesday and Friday. Okay? So, is there anything that you would like to ask on? We're just going to say, we got more time, but I want you to work on that individually. Is there anything that you would like to look at on worksheet 2 that you feel you would like to look at? Yes. Once. Going twice.